It's one of the oldest names in mining equipment, Marion. More than 100 years ago, Henry Barnhart saw ways to improve the steam shovels of his day. With Edward Hoover and George King, he founded the Marion Steam Shovel Company in Marion, Ohio. In the late 1800s, when a network of railroads was built across the United States, Marion was there. Later, when huge amounts of coal were first dug from large surface mines, Marion was there. When thousands of workers cut through the American continent to build the Panama Canal, Marion was there. And when some of America's biggest hydroelectric projects were built, digging was done by Marion machinery. Much later, Marion even had a role in America's space program, supplying the crawler transporters that are still used today in the space shuttle program. From building 19th century railroads to moving the space shuttle to the launch pad, some of the largest mobile equipment ever built started at the Marion facilities. Today, that equipment includes the draglines, shovels, and drills needed around the world to uncover vital mineral resources. Marion draglines are used to strip millions of tons of overburden. Weighing up to 17 million pounds, these machines have been continually upgraded, utilizing the latest engineering technology. An example of Marion's leadership is this planetary swing system. Utilized on our largest draglines, the entire swing module is located within the rotating frame of the machine and permits greater power to be applied while reducing critical stress on gearing components. In 1991, Marion was granted a patent in recognition of its unique design. Marion offers 8 dragline models, ranging from 10 to 180 cubic yards of bucket capacity to meet virtually every mine's stripping requirements. Marion's 8000 series draglines provide the capacity, productivity, and reliability for the world's largest coal mining operations. Engineering advances have enabled Marion to increase the productivity of comparably sized models by more than 20%, while increasing reliability as well. To supply machines with this level of productivity takes several years of work. It begins with designing to a customer's individual requirements, through manufacturing and a complex erection process. Each step of the way, our experts are there working closely with the mine's personnel to ensure the best machine in the business goes to work on time. Marion's smaller walking drag lines, the 7000 series, are still mammoth by most standards. The 7820 with a 35 to 45 cubic yard bucket has recently been chosen by customers in Australia and India for major new coal mines. And at the small end of the spectrum, Marion offers the 7250, a modular walking dragline designed for quick assembly and disassembly when mine operations may not last as long as the machine itself. Although the unique walking mechanism of our largest draglines provides the mobility most large mines require, in many instances, the added mobility of a crawler machine is needed. Marion's crawler draglines meet this need with the same high productivity of a walking dragline. Marion engineers extended the capacity and reach of these machines with the recent introduction of the world's largest crawler dragline, the 305M. The 305M, now operating in Australia, utilizes a host of engineering innovations, including an energy-saving flywheel system to provide a crawler dragline that's more than 50% larger than any competitor's machine. While the productivity of a walking dragline is unrivaled in direct cast operations, digging and loading ore and overburden requires a different kind of excavating tool, Marion's line of large electric mining shovels. Ranging up to 2.3 million pounds in operating weight, our shovels can handle dipper payloads from 15 to 85 tons while cycling in about 30 seconds. In 1986, years ahead of the competition, Marion commissioned the first mining shovel capable of loading the newest generation of 240-ton trucks in just 3 passes. State-of-the-art features like planetary drives on all motions make the 301M the most advanced and productive shovel in the world. With many units now operating in major mines in the U.S., Canada, and Australia, it sets the industry standard, and Marion engineers have applied advances made on the 301M to other shovel models, including the 204M Super Front shovel. With its unique front-end design, this shovel operates better in low banks or pitched seams. The 201M is a proven match for 120 to 170 ton trucks. The unit shown here is operating in an African uranium mine and incorporates the dual-motor lower frame planetary propel pioneered on the 301M. When mine production plans don't require the capacity of Marion's largest shovels, the 191M is frequently the choice. This machine is just one of 23 selected by the Turkish coal enterprise in the mid-1980s. At the small end of our shovel line is the 182M. Its 20-ton payload and proven, reliable design made it the choice of India's largest coal producers as they expand production in the 1990s. As powerful as Marion's shovels and draglines are, mines can improve excavator productivity by first blasting the material to fragment it. Large rotary drills are used to drill blast holes in the rock formation. In the early 1970s, Marion began offering these large blast hole drills to complement our shovels and draglines. These units can drill holes up to 15 inches in diameter, applying 130,000 pounds of force to the drilling bit. When the latest Marion drill was shipped to a South Africa coal producer in 1991, a group of 4 Marion drills shipped to a U.S. copper producer nearly 20 years earlier were still at work after drilling an incredible 22,000 miles of blast holes. While our draglines, shovels, and drills continue to work for mining customers around the world, Marion continues working to ensure their performance. Marion's production facilities contain some of the largest and most sophisticated metalworking equipment in the world. Despite component dimensions measured in feet, tolerances are often measured in thousandths of an inch. Marion employs a variety of testing techniques to provide the quality assurance needed to make Marion machines perform to the highest standards. The skill, experience, and investment in people and equipment that goes into building our machines in the first place are also applied to the job of keeping them running. An excellent example of this is the Marion Right Weight Bucket. Our knowledge in dragline design and experience working with customers around the world are applied to a line of dragline buckets that maximize machine performance. This doesn't always mean the largest capacity bucket, but one that can stand up to a particular mine's digging conditions, minimize downtime, and handle the load for which the Marion dragline was designed and built. Any machine that's expected to operate as much as 8,000 hours a year needs a full range of parts and service support, and we strive to provide the best in the business. Marion produces replacement parts to the same standards as the new equipment and often incorporates design or manufacturing improvements to make our replacement parts even better than the original. And Marion stocks a multi-million-dollar inventory in strategic locations around the world. Our parts manufacturing program includes the rebuilding of major components supplied by the customer at a fraction of the cost of a new part. When done by Marion, these rebuilds get the same new parts warranty for all material and workmanship provided. When field support is needed, Marion is there. Trained field specialists have the most advanced equipment available to assist mine operating and maintenance people. Field machining, boom raising and lowering, machine relocation, inspection programs, and a host of other service functions are provided by Marion's Customer Service Department, with the full support of the entire Marion organization. From the first sales contact to the day a Marion machine goes to work, year after productive year, everything Marion does is focused on helping our customers produce efficiently, reliably, and cost-effectively. As the sun sets at the Safer Fontaine Colliery in Transvaal, South Africa, the afternoon shift is underway in an eastern Texas lignite mine. And the morning crew is due to arrive at a huge Australian coal mine. In each case, and nearly 100 more just like them, a Marion 8000 series walking dragline is hard at work, uncovering vital coal and other minerals that help fuel the world's economy. In fact, since the first Marion walking dragline was built in 1939, these machines have been the industry standard for productivity, reliability, and durability. The 8000 series draglines introduced in the 1980s include performance features like outboard bearing propel, 4-chord deep section boom, and over-under fair lead. Marion's planetary swing system was developed in the late 1980s and applied to large Marion draglines. It provides greater machine capacity and swing power within the confines of the existing machinery house. Planetary gearboxes require only a fraction of the space needed for conventional parallel shaft swing gearing. Locating the gearbox on the bottom plate inside the rotating frame eliminates the long shaft that drives the final pinion. It is simply supported by a bearing at each end of the shaft. This innovative swing design was granted a U.S. patent in January 1992. Marion also offers the integrated control, diagnostics, and monitoring system for drive supervision, anti-tight lining, and many other control functions not associated with the drive system. This software-based system utilizes a color CRT, keypad, and easy-to-learn English language-based software. Automatic lubrication control and fault annunciation functions use solid-state electronics instead of electromechanical relays and timers, which require costly maintenance. In 1983, Marion sold a Model 8750 dragline with a 400-foot boom and an allowable load of 450,000 pounds. It was judged to be the most reliable and productive machine on the market. In 1989, Marion made dramatic changes to a new 8750 to meet customer needs. We incorporated a new elevated tri-structure and related front-end design changes. The working weight of the machine is about the same, at 14 million pounds. But these changes enable Marion to increase the allowable load by 100,000 pounds, more than 20%. We also increased the boom length to a world record 420 feet. To maintain cycle time, horsepower was increased by 40%. T-cast sections in supporting bulkheads are located under the roller path area. They were developed using extensive finite element analysis of the complete roller support system. The roller circle uses flangeless, tapered rollers of forged heat-treated steel. A guide thrust rail is incorporated into the design of the lower rail to maintain roller circle concentricity. Field machining promotes accurate rail, roller, swing gear, and center pin alignment throughout the machine's service life. These improvements have translated into superior performance and reduced downtime. A number of customers operating older Marion draglines have chosen to have Marion upgrade their machines. Over 100 8000 series draglines operate around the world with a host of proven features. One of these Marion innovations is outboard bearing propel. The eccentric cam incorporates an outboard bearing cam support that provides a smooth, efficient movement. 4 wide flange boom cords are used for equal load sharing. All welds are visible for easy inspection. The simple joint and cord design eliminates the need for complicated high-pressure crack detection systems. All Marion draglines are equipped with trunnion-mounted boom point sheave assemblies. They allow for a plus or minus 30-degree angle that the swivel may assume during digging operations. They can be easily removed for repair or replacement. The over-under fair lead allows longer drag rope life and reduces maintenance. Marion's operator's cab is the control center for these huge earth movers. It contains the primary controls and indicators. It is designed to reduce or eliminate distractions and improve operator efficiency. The operator's seat and controllers are ergonomically designed with right and left-hand joysticks for all primary motions. Marion engineers utilize the same extensive design expertise and field testing to develop a better performing, right-weight bucket. Each bucket is designed with characteristics to optimize production. A three-taper design for the sides and bottom plate allows material to flow in and out of the bucket with ease. The bucket structure minimizes weld joints. The corners are rounded and blended, and the top rail design provides resistance to side loading. The lip, arch, teeth, and cheeks are designed as a solid steel digging unit. Recognized as the state-of-the-art in dragline design, the 8000 series is being continuously upgraded by Marion. Over the past decade, Marion has sold more large walking drag lines than anyone. They're moving more rock at lower costs than ever before. Marion 8000 series drag lines, serving you with reliability, serviceability, and higher production.
In a unique display of teamwork and skill, Callide Coal has built one of Australia's biggest walking draglines. The story of the building of Callide's dragline begins with Callide Coal's plans to increase coal production to meet an upturn in customer demand. The Callide coal deposits, located nearly 80 metres below ground level, meant a machine with both deep digging capabilities and large bucket capacity was needed. Callide's existing Bucyrus Aries dragline could not reach the depth required in major seams. Operated as a joint venture by Shell Australia and AMP, Callide Coalfields is a significant Australian black coal producer. The Marion 8750, when completed, would maintain Callide at the leading edge of coal production in Australia. Planning for construction began in January of 1992. A team of skilled professionals was assembled to undertake one of the largest single construction projects for a coal mine in Australia, and to complete it safely and on time. A 10-acre site adjacent to the Callide coalfields was cleared. Construction commenced in June of 1992. Building a machine the size of a 21-storey building that weighs as much as an ocean liner brought together international experience and broke new ground in construction technique. Successful design and supply tenderer was the Marion division of the Indresco Company from Ohio in the United States. Indresco personnel quickly became involved in the project and remained on site to oversee the construction and help with design modifications when required. The erection crew chosen was the Mackay-based Arden Engineering. At times, more than 90 people worked on the job. But it was the teamwork that saw the $80 million project completed well ahead of schedule, under budget, and remarkably, with no lost time injuries. A credit to Shell Australia's commitment to safety. The first consignment of equipment for the 8750 arrived on site in June of 1992. Most of the steelwork was manufactured by Evans Deacon Industries in Brisbane. Proprietary equipment, including the gearboxes, the motors, the motor generator sets, and the propel mechanism, were manufactured in the United States and shipped across. Dragline erection requires the construction and assembly of 5 main segments: the tub, the revolving frame, the machinery house, the tri-structure, and the boom. Measuring 24.5 metres in diameter, the tub is made up of 21 major sections, the heaviest weighing 60 tonnes. Welding the sections together took 4 months. Laser-controlled equipment was designed and built especially for machining the rail and roller path. The laser-controlled equipment is deadly accurate, considerably reducing both machining time and the likelihood of mistakes. The revolving frame allows the dragline to rotate about the centre pin of the tub. The frame supports the electrics and machinery that control the dragline. It also supports the boom, the tri-structure, and the walking mechanism. The front section of the revolving frame weighs 1,200 tonnes. It's made up of 21 major sections, the heaviest weighing 102 tonnes. The ballast section of the frame weighs 400 tonnes, and it contains 500 tonnes of scrap metal to balance the machine during dig and walk operations. In constructing Callide's Marion 8750, a significant new approach was taken in building the tub and the revolving frame simultaneously, then lifting the frame onto the tub. Heavy lift transporters moved the 1,200-tonne revolving frame onto the 740-tonne tub. Lowering the revolving frame onto the tub required pinpoint accuracy. This new approach to construction contributed to the dragline being finished 4 months ahead of schedule. A major milestone in the dragline's construction was the raising and pinning of the tri-structure to support the dragline's boom. These scenes, filmed over a 5-hour period, show the erection of the 260-tonne tri-structure into place. 20 personnel were involved in this lift, involving specialist crane experience from Lamson, Australia. A transi-lift crane with a working boom length of 79 metres raised the 64-metre high tri-structure. After the tri-structure was erected, the dragline was visible from the neighbouring township of Biloela, almost 10 kilometres away. The pins which locate the structure in position weigh almost 2 tonnes each. The structure is supported by 2 back legs, each of approximately 65 tonnes. The machinery house is the dragline's nerve centre. State-of-the-art circuitry and electronics bring to life the intricate workings of the dragline. The house is pressurised with filtered air to provide cooling to the electrical and mechanical components and to protect them from dust and moisture. The fixing of the roof in place marked a major turning point. The dragline was beginning to take shape. The fixing of the house panelling would move it a step closer to completion. The dragline's 128-metre long boom is the longest in the world. It stands 80 metres tall. Raised at an angle of 36.1 degrees, the boom has a dumping radius of 114 metres from the foot of the dragline. It can support a load of 239 tonnes and dig 60 metres below the digging bench. The dragline bucket appears small in comparison to the mobile giant from which it operates. The bucket capacity, however, is almost 80 cubic metres. Bucket size and boom length have been perfectly matched to achieve maximum productivity. The bucket is controlled by 4 steel cables, 12.5 centimetres thick, 2 that hoist the bucket and 2 that drag it. Raising the boom into position was another of the major lifts undertaken during construction of the 8750. Although it took only 5 minutes to lift the boom into place, many days of planning and preparation guaranteed the lift would succeed. The raising of the boom was a milestone everyone looked forward to. Finally, the 8750 was almost ready for work. Machining of the hook rail took place over 2 night shifts. The machine revolved continuously as the cutting mechanism machined the rail onto which the hooks grabbed to lift the tub during walk operations. To harness enough power to run the dragline, Callide draws 22,000 volts from Queensland's power grid to a bank of 3 motor generator sets. These generator sets convert the voltage to DC power to feed a dozen 1,300 horsepower motors which drive the hoist and drag drums. Callide has looked to the future and made provision for upgrading the dragline to include another motor generator set and extra drive motors so a larger bucket can be used. Just 1 year and 6 months after construction started, the Marion 8750 took its first step. The dragline, weighing 6,800 tonnes, walks 2 kilometres an hour in 2.5 metre steps. The long-awaited walk off-site to its first place of deployment was a much-anticipated move for Shell, Callide Coal and the team that had provided the skill and dedication to build one of the world's biggest walking draglines and the most modern piece of equipment of its type in the world. Callide Coalfield's Marion 8750 dragline is an impressive example of man's quest to utilise technology for greater efficiency. More impressive is Shell's commitment to efficiency and productivity that has led to another Australian first.
world's mining industry turned to larger, more productive shovels in the mid-1980s, only one supplier was there with an 85-ton payload electric mining shovel designed from the ground up to three-pass load the new generation of 240 to 255-ton payload trucks. That supplier was Marion. Since 1986, the Marion 301M has been operating in some of the largest, toughest mines around the world. The first two went to work in a world-class iron ore mine in Western Australia. Others now handle tough jobs in some of the largest coal mines in the Powder River Basin of the western U.S., remove overburden in the harsh climate of northern Canada, and work in several large Australian coal mines. The 301M continues to prove its worth. The design of the 301M incorporates a host of advanced features that enable it to be more productive and reliable. For example, planetary drives on all motions provide efficient power. They are more compact, lighter weight, and easier to service with plug-in replacement gear cases. The 301M is the only shovel that uses them on all motion drives. One of the keys to keeping a shovel running in harsh mining conditions is its lower frame and propel. The 301M features a rugged lower frame with bolt-on crawlers. The drive sprockets are elevated to eliminate digging forces and steering loads. The pitch-seeking sprockets allow the 301M to operate with over 1 inch of pitch extension in the crawler shoes. The 301's dual motor lower frame propel provides skid, differential, and pivot steering to meet any mine's travel requirements with ease. A complete drive is mounted on each crawler assembly, and gear cases are compact modular units with disc brakes mounted on each motor. The machinery house of the 301M is designed in distinct modules for fast, easy field assembly. They are shipped to the field complete, with all electrical cabinets pre-wired and tested. The operator's cab has been human engineered for safety, comfort, and productivity. Operating controls are conveniently positioned with joysticks for all primary motions. The front end of the 301M was computer designed to allow the dipper to cut through the bank with uniform cutting forces at all handle positions. The major front end structures have been subjected to finite element analysis to ensure they stand up to stresses and impacts of tough digging. This design allows the yoke block to be mounted on trunnions located on the boom, not on the shipper shaft. The shovel's boom point sheaves are identical pre-assembled modules that are mounted in anti-friction bearings and lubricated by the auto lube system. Another example of the machine's serviceability. The hoist, swing, and crowd machinery on the 301M maximize dipper fill while cycling in about 30 seconds or less. Driven by two DC motors, the rack and pinion crowd drive is electronically controlled to balance the load transmitted to the single handle rack. The hoist machinery provides optimum bale pull, generating greater cutting force for quicker dipper fill. Marion engineers designed the 301M with the highest swing torque in its class. Driven by two identical motors, the swing assemblies are compact modular units. The 301M incorporates the most advanced electrical drive system available, static power conversion. This system has distinct advantages over competitive DC or AC shovel drives. Motion drives utilize variable voltage DC with proven DC motors. Static reactive power compensation is used to regulate power factor during the digging cycle without the use of switch capacitors. Solid-state programmable logic controllers are used for auto lube, hoist, and crowd limits, and system diagnostics. The collector rings and roto-seal assembly are mounted above the center journal on the upper frame for easy, safe access for servicing. The 301M's electrical system features a sophisticated yet easy-to-use diagnostic system, beginning with the 18-point annunciator panel in the operator's cab and 72-point monitoring panel in the machinery house. This system allows for both speed and accuracy in troubleshooting potential electrical problems. LED lights and alarms alert the operator if a potential problem occurs. Maintenance personnel can trace the problem further through first fault diagnostics on the electrical cabinets. An event logger monitors over 150 separate events for additional diagnostic information. From its dipper teeth to its crawler shoes, the Marion 301M is designed and built to lower your operating cost. It is specifically designed from the ground up to match the new generation of large haul trucks. The first 301M has logged more than 20,000 operating hours. And another 301M, operating in tough digging conditions, produced more than 2 million bank cubic yards in a single month, or more than 1.5 million cubic meters. Backed by more than a century of shovel experience, the Marion 301M is ready to meet your mine's toughest challenge.